This is Professor Darif Seitz. This Java tutorial is about graphical user interface layout classes. Here's a class diagram showing the main classes involved in layout. In the upper left is the container class, which is a base class for all the components. Container has a function to add components to it, so it contains components. All the other components that inherit from it also have that ability to act as a container. Container also has a set layout function, which allows a layout manager to be specified for the container. Layout managers organize the content in a container according to different layout policies. Up at the top here is an interface for layout managers that they must implement. The methods in there, in that interface, are things specific to rather low-level operations, so I don't show them here, but it's important that the layout managers do implement that interface so they're recognized as layout managers. There's 4 layout managers we're going to focus on here in this tutorial, and some other ones will be briefly mentioned over here. Before we get into the layout managers, we're going to look down here underneath container. First is JComponent. The components are the visible things that are put into containers, and JComponent is the base class in the Swing class library for the components. The ones that inherit from JComponent, all of the components do that, but many are just listed in this note here that would take up too much space to show them all. In terms of layout, the components inherit a set alignment X, which can be used to specify a horizontal positioning of a component within a reserved area, a left, a center, or a right positioning. And they also inherit a set alignment Y, which can be used to specify a vertical positioning within a reserved area within a layout manager layout of top or bottom and or center. And also there's a set border. Set border can be used to add a border to the perimeter of any component. You have to be a component in order to do that. The borders can be like lines around the perimeter or different kinds of insets or outsets, and they can also be empty space used to provide like a margin or padding, and that affects the overall layout look, having that space to separate things. So those abilities are there in JComponent. Looking at the layout managers next, we'll start with the border layout. Border layout is the default layout manager for the JFrame class. JFrame is the main window frame that's used in a GUI application. It's not shown here, but border layout has regions that it maintains. It has a north, a west, a south, and an east region, and then in between those a central or center region. The center region expands to fill the available space provided by the size of the window. Next, we'll talk about flow layout right here. Oh, by the way, on border layout in the constructor, you can specify a horizontal gap and a vertical gap, which is a separator or empty space between the regions. Flow layout, it lays things out from left to right in rows, putting them as they're added to the container one by one, and when it runs out of room, reaching the end of the window, it wraps to the next row. As you resize the window, components may flow down to another row if the window gets smaller, or flow up to a higher row if the window gets wider. And Flow Layout is the default layout manager for JPanels. It also has an alignment specifier in its constructor. You can say that you want your components to be left justified or center justified or right justified as a group within a row, and that's the alignment. Also, there's ability to specify a horizontal gap and a vertical gap. Grid layout is a checkerboard-like grid. You specify the number of rows and columns. Each cell is the same size, and when you add components, they're added starting at the top left and moving to the right, and then when they fill up the first row, they move down to the second row. So there is no way to put a component in a particular grid. They're put in the order that they are added to the container. And all the cells are the same size. You specify the rows and the columns, and there's also the ability to have a horizontal gap and a vertical gap specifiers in the constructors. A box layout is a layout manager that is either a single row or a single column. And if you put things in a column, they go in at the top, and then the next one goes underneath it, and the next one underneath that. They don't go side by side because that would become a row. So if you want things like that, you have to put them inside a panel and put that in the box, so that the panel is the one item in that column entry, and then inside the panel it can have multiple other entries. And that's a common theme here across these layout managers. Border layout, each region can only accept a single component. If you want to have multiple components in a region, you have to put a JPanel in there, and then that's the single component, and within it, it will manage whatever components are added to it. The grid layout is the same thing. Every cell can only have a single component. Now, flow layout, you just add components and they flow across the row and then down to the next row. And box layout, as we've noted, also in the column, each column entry has to be a single component, or each row entry has to be a single component. Over here are some layout managers. There's a card layout that is like a stack of cards, and you just see the top one, and it can be switched which is the top one. A grid bag layout is similar to a grid, but it's more sophisticated. It allows the cells to have to span multiple of their cells, other cells. They don't all have to be the same size. Group layout and spring layout are more sophisticated layout managers that are used for graphical user interface builders, such as the one in NetBeans, which uses the group layout as its layout manager for the code that it generates. A JPanel, as has been mentioned, is a general purpose component that contains other components, and you can use JPanels to create a component hierarchy, a nesting hierarchy, to build a very rich user interface and lay it out precisely how you want things. For the box layout, there's a class called box that has static functions. One of the static functions is create a horizontal box, another is create a vertical box. They will give you the horizontal or vertical boxes that have the box layout as their layout manager. And in the box layout, the components are placed next to each other without any space between them, either in the same column or in the same row. To get gaps, you use invisible components. There's two kinds. There's a rigid area, which you specify the size through a dimension, and the box has a static function to create a rigid area. Then you add that, and it's a spacer between the components in the box layout. Or there's another kind of invisible component called glue, and it will stretch to take up the available size that's available when the window resizes. So that way the individual components themselves do not stretch. The box layout is a good layout manager to respect the preferred sizes of components. It does not change them, it respects them. Finally, there's borders. There's a border interface which has implementation in an empty border and a compound border, and there's a border factory that can be used to create an empty border, create a line border, create a titled border that has a title in the top of the border. And so the borders, like the empty borders, you tell the top, left, bottom, and right gap that you want so that you can get sizing around a component with an empty border, or a line border is actually a line. So the borders also have the ability for any component that can set a border to influence the layout look. So this covers this class diagram. I think we've talked about everything in there, and you can see how having this picture, this mental model of the layout classes involved, will help you to have a better traction on how to use these things.